Okay, hi guys. We have the MATLAB neural networking system. We're going to explain how it works with MATLAB and go from there. So my name's Alonna and I'm with Shin. Okay, so here we have what is neural networking. This diagram over here is a basic diagram of what a neural network is, and right here we have the input layer, which is the user putting in information to the system. Then we have these connectors here. They have weights on them, and then they go to the hidden layer, which is right here. And the hidden layer is where the algorithm actually forms. The activation function is determined here, and the system actually understands it and tries to figure out a way to get the best result, and that goes out to the output layer. Okay, so here we have what neural networking is again. We're saying that the neural networking is meant to be a small-scale brain. It demonstrates how people think and make decisions. So the program would actually use your inputs that you're giving it and understand that and try to figure out some type of output that is the best results of how it goes through. The brain, explaining that, like how it actually compares to it's like the synapses in the brain. So the connectors would be the synapses, and then the neurons would be the nodes that you saw with the input layer, the hidden layers, and the output layers. The hyperparameters establish the structure and behavior of the system, and then it can also be compared to forecasting. So if you would actually input some different values for the particular questions of that system, it would actually have the output that it predicts would be correct. In general, it's just receiving the inputs and then analyzing them and with the given conditions that you give it and outputting the best result. So right here we have that it has something called a learning rule, which is also understood as the training of the data. So I'll explain that further in the next slide. It mimics the human brain, like I said previously. It thinks in patterns and stuff like that. And then there's many examples of neural networking. We also have, there's one for facial recognition, and then in MATLAB there's other examples which we'll explain further. So right here we have the MATLAB default code. They already have one in there in place for you to go through and understand, and we'll be using that later in this video. So we have the components defined by the user. So this is what you have to determine. The inputs, so you have to determine the questions and give it a specific value. For ours we had yes and no values. And then the target value, you have to input that as well, so the results that it would have for those particular scenarios that you're giving it. And this will be called a supervised regression model because you're giving it something to go by in order to understand it. And the user also determines the number of hidden layers that are in the system. And those are the things that I explained further. You can have different hidden layers. It also helps it train better depending on the number you have.
So to continue on our presentation, we're going to do a quick demonstration of how MATLAB works with an example that MATLAB already has. So on over here we have MATLAB open, and we want to get their pattern recognition open, and usually we could go to apps and then click on neural networking pattern recognition, or we can go through the quick shortcut is to type NN start in the command window. Here we can pick the pattern recognition app, which is what we'll be using, and then a quick introduction of what it does pops up. We're just going to go ahead and click next. Over here we're going to load example data set using a wine vintage of 13 categories. And we're going to go ahead and import that and click next. We're going to keep the default validation and test data and click next. And then the number of hidden neurons we can play around with. It can be from 10 to 12 for it to be like a good amount. And then we're just going to go ahead and keep 10. Now here they let you train the data that it already has. And so we're going to go ahead and do training. So once we train it, this little dialog box will pop up, and under plots it will have visual representation of the results. It will have its performance plot, its training state, its error histogram, and a confusion matrix of how the results were categorized and whether they were categorized correctly or not. and then a receiver operating characteristics, which is basically overall of how it classified, and the farther to the left, the better. Now we're back to the PowerPoint to quickly explain the results. The first one we'll be doing is the performance plot, and what the performance plot does, it graphs the performance between the error versus the number of cycles for the training and the validation and the testing data.
So secondly, we have the training state, which basically shows, it records what MATLAB is doing in the system. So as we can see for the wine vintage, it's actually trending pretty well for this example.
So moving on to the confusion matrix, what this shows is it shows how accurately the results have been classified. And over here, the green boxes show how many correctly were classified. The red shows how many incorrectly, and then the blue is just an average percentage of those results. So during its training stage for this wine vintage, it was 100% classified correctly. Versus in the validation stage, only about 88% of it was classified correctly, but in the testing stage, it classified correctly 100%. And what this fourth box does is it shows an overall result of how well they were classified. And for this specific result, it only classified about 98.3% correctly. Over here we have the receiver operator characteristics, and this shows the characteristics for each output class. And how to read this is it graphs each of your stages, and the closer the line is to the top left corner, the more accurate or the better the classification was.
Okay, so here are our references, and this concludes the part 1 of this video. So go ahead and head over to part 2 to explain our scenario of what we did in MATLAB.